an object is placed on the inclined plane. Okay, a block is placed on the inclined plane. So let me mark the angle. Let's say this angle is given. The value of the angle is theta. So this angle is given as theta. Now, let us now label the forces acting on the block. So several forces would be acting on the block. Let us draw all the forces. The easiest one is the force which would be vertically downward or through the center of the mass vertically downward. This is what we call weight. Then the normal contact force would be here. So these two we have marked initially. This is the normal contact, and the one vertically downward is weight, or you can write it as mg. Let's write it as mg. Okay, up next, let's say the block is now pushed forward up the slope. So someone is standing here, he is pushing the block up the slope. So the direction of the driving force is up the slope. So let me draw that force over here. Sorry, the direction of the this force would be up the slope. So this is the driving force. What else? If this is the driving force, then there has to be a force against the direction of motion. So if the block or if the box is accelerating up the slope, then the friction has to be down the slope. So in this case, we do have a friction as well, which would be down the slope. So I'm drawing the value of friction here, the vector of friction here, just to differentiate these vectors. This is a friction one. Now let me resolve the components of weight. Let me resolve weight into components. So instead of drawing this driving force over here, I can draw the driving force on the front side, but I'll just make sure that direction wise it remains same. I should not be changing the direction. It should be drawn in exactly the same direction, which is up the slope. So this is the direction of the driving force. I'm being very careful with the direction. So the driving force is up the slope. So I can raise off the driving force from here, because on this side I have to draw two components of mass. Sorry, two components of weight. So one of the component would be over here, and the other rectangular component or perpendicular component would be over here. And like I explained already, if this angle is theta, then this angle is also theta, and hence this component which is connected to the given angle would be mg cos theta, and the other one would be mg sin theta. Now let us write the equations for this case. Since there is no acceleration perpendicular to the slope, means there is no acceleration in this direction, so these two forces are equal. R equals to mg cos theta. There is no acceleration in this direction. Secondly, there is some acceleration in this direction. So I have to write first F resultant equals to ma. Now what is the resultant force in this direction? We have three forces. One of the forces up the slope, which is the driving force, the force that the person is exerting to push it up the slope. So that force is upward. And there are two forces down the slope which are working against us. They're working against the person who is trying to push the block up the slope, but two forces are working against him. Mg sine theta, a component of the weight, and the friction. So what is the resultant force if the acceleration is up the slope? It means this force is still greater than the forces down the slope. So the expression would be Fd, the driving force, minus the forces which are down the slope, minus mg sine theta, minus the friction, and that equals to ma from the formula. Now this is the value of the resultant force in this situation. Now for this one, many of the values would be given and you can be asked to find a specific value. For example, the friction, they can ask you to find friction, they can ask you to find acceleration, but meanwhile the other quantities would be given. And whenever you have this situation, and generally they link this situation with the concept of work, power, energy. You'll see in that chapter we will be having these kind of questions. How much work has to be done by the person to push it up the slope, or what is the power produced, and these kind of situations. So this is the last case of the inclined plane. Now what if the inclined plane is smooth? If the inclined plane is smooth, that simply means the frictional force would not exist, and hence the new expression for this situation would be Ft minus mg sine theta equals ma. Why do we say so? Because in that case, if there is no friction, now only one force is working against the person. The person was trying to push it up the slope. Only one force is working against him, which is mg sine theta. So technically it is not a complete force, but just a component of weight. So if you ask me which is the component which is responsible for the block sliding down the slope, the answer would be mg sine theta, provided theta is the angle of inclination.